Okay, so my project is about creating a collision avoidance system for a drone. So in this case of my project, I've utilized an AR Drone 2.0 and 3 systems which I've created and integrated in order to allow me to create a collision avoidance system for the drone. So the avoidance system works like this. Whenever I have an object that breaches a threshold of 18 inches that I've set, the drone will move backwards. So for instance, let's present the drone with an object. Whenever this object will surpass that 18-inch barrier, the drone will move back, overriding my user control until the drone reestablishes that barrier. Then user control is returned. So in order to allow this to work, I have 3 systems. The first one is mounted on top of the AR drone. It utilizes an Arduino Mini, which controls a ping ultrasonic sensor. The ultrasonic sensor constantly measures distances, and whenever it reads a distance that is less than 18 inches, the Arduino Mini will send an alarm signal via a RF transmitter, which is ran by virtual wire, and it will send the signal to an RF receiver, which is mounted on top of a second system that I've created. This system is a remote. And so on this remote, I have a joystick shield with a joystick and 6 buttons actually, and 4 potentiometers and an LCD screen. On this LCD, I have certain settings that I can change for each of the speeds for my lateral control and my vertical control, which is set by these potentiometers. Now, this all works, but when I get an alarm signal via the RF receiver, the whole remote will override my user control and tell Node.js, which is run on a computer, which is part of my third system, it will tell the drone to move back. The Arduino Mega will collectively take all my user inputs and everything and mash them into numbers, from which it can send over USB and serial line to my third system, which is Node.js ran on a computer. For example, let's take the number 21. Node.js will translate 21 into a action of going back with the speed of 1. This depends on my user settings and where I'm maneuvering the drone to, all of that. And Node.js takes all these numbers, translates them, and the computer is connected to the drone via Wi-Fi, and the drone uses that to control the drone. I've also created a fail-safe system just in case the system doesn't work. I can just simply pull this jumper wire, and control is always returned to the user just in case the system doesn't work. Now, let me run through my test cases.